All right, let's dive into a problem that quietly costs the global banking industry billions of dollars every single year. Seriously, it's this massive manual headache that happens completely behind the scenes. We're going to look at a groundbreaking new paper that proposes a fix. And get this, the idea comes straight from the mind-bending world of quantum physics.
So, first things first, let's unpack this huge, hidden challenge. It's something that plagues pretty much every bank on the planet every single day. The official name for it is reconciliation. And yeah, I know it doesn't exactly sound glamorous, but trust me, it is the absolute bedrock of all financial integrity.
And just to give you a sense of the scale we're talking about here, imagine trying to match up 100,000 different transactions. That was the biggest data set they used in the study. But here's the real challenge. Almost none of the records line up perfectly. So it becomes this huge, astronomical game of connect the dots. And there are literally billions of dollars hanging in the balance.
You know, at its heart, reconciliation is a pretty simple idea. It's all about making sure the numbers in one system match the numbers in another system. But this isn't just about tidy bookkeeping. No way. It is absolutely crucial for accurate financial reporting, for managing risk, and for meeting all those super strict regulatory demands.
Right. But what happens when things get messy? And I mean really messy. We're not talking about clean, simple one-to-one entries here. We are dealing with a flood of data, and it's all filled with these tiny differences, delays, and super complex relationships. And this is exactly where the old school ways of matching things up, well, they just completely fall apart.
And this brings us to a really key point. The old way of doing things is breaking. I mean, these rigid, rule-based systems, they were built for a much simpler time. They're just totally struggling to keep up with the messy reality of modern finance.
Yeah, think about it. In the past, matching was often a simple one-to-one game, right? One deposit, one invoice. Easy. But today, it's a whole different story. The problem has morphed into this incredibly complex web. You might have one single payment that covers dozens of tiny invoices, or maybe multiple payments all get rolled into one settlement. It's a many-to-many world now, and that changes everything.
So what this means is that banks are facing two huge challenges at the exact same time. First, you've got that many-to-many complexity we just talked about. But second, there's something the paper calls tolerance matching, and this is really important. It basically means that transactions almost never match perfectly, right down to the last cent. Why? Because of tiny things like fees, currency conversions, or just rounding differences. So any system has to be smart enough to handle both of these problems at once.
And the paper really just hits the nail on the head here. The old way of doing things, the one that relies on this long list of really rigid, if this then that rules, it just wasn't built for this new reality. These systems, as the author says, are fragile, they're imprecise, and frankly, they just can't scale.
And this diagram from the study shows the problem perfectly. So you've got the old role-based systems on one side, and then a slightly better approach called a greedy algorithm, which just kind of looks for the next easiest match. And yeah, there's some overlap. But look at that huge section that is completely unique to QUBO. This new approach is finding a whole bunch of correct matches that the other systems miss entirely. They're literally leaving money and critical data just sitting there, unmatched.
Okay, so what's the fix? Well, the big breakthrough here is to completely change how you even think about the problem. Instead of working through a long checklist of rules, you treat the whole thing like a giant puzzle. And your only goal is to find the one single arrangement that fits together the best. It's a huge shift from thinking in rules to thinking in terms of optimization.
The tool they use for this is called QUBO. Now I know, the name sounds super complex, but the idea behind it is actually pretty elegant. It takes this entire messy, tangled problem and reframes it as a single equation. The best way to think about it is like a landscape with hills and valleys. Every possible way you could match the transactions has an energy level. The wrong matches, they're way up on the high, unstable hills. But the single best solution, that's at the very bottom in the deepest, lowest energy valley. The whole goal is just to find that one perfect spot.
So here's a look at how the process actually works. Step 1, you just define your two sets of data, the stuff you need to match. Step 2, you build that single QUBO equation we were talking about. Step 3, you basically unleash a special kind of solver to go find that lowest energy solution. And then step 4 is really important for making this work in the real world. Instead of trying to solve one gigantic puzzle all at once, you break it into smaller, more manageable windows. That's what keeps it fast and scalable.
Now, this is a really critical point I want to make. We are not talking about giant futuristic quantum computers here, okay? The term is quantum-inspired.
which means we're using algorithms that are based on the principles of quantum mechanics. But, and this is the key, they run super efficiently on the classical computers that banks already own. This isn't science fiction. This technology is practical and it's usable today.
So, the big question, right? Does this whole quantum-inspired idea actually work any better? Well, the paper puts it to the test, head-to-head against the old methods. And let me tell you, the results are incredibly clear.
I mean, the difference is just staggering. On that huge data set with 100,000 transactions, the old rule-based system left more than a third of everything unmatched. A third! The QUBO method, it successfully matched almost 88%. That is just a monumental leap in performance.
And that translates directly into saving a ton of human effort. So this chart shows what's called the exception rate. An exception is basically any item the system can't figure out, so it has to get kicked over to a person for review. With the old system, more than 28% of transactions needed manual work. Look at what QUBO does. It slashes that number all the way down to just over 8%.
And here's the thing, it's not just better, it's also fast enough for the real world. That's what this graph shows. It proves the method is scalable. As you throw more and more transactions at it, the time it takes to get the answer grows in a really predictable, manageable way. It's not going to just buckle under the pressure of a real massive banking operation.
So let's wrap this up by looking at the future here. Because this isn't just some clever algorithm in a lab. It has profound real-world consequences for how banks actually operate day to day.
I mean, here's the bottom line number you need to remember. Over 60%. The study found that this QUBO method leads to a greater than 60% reduction in the number of items that need to be manually investigated by a person. Compared to the old systems, that is an absolute game changer.
So what does all this mean for a bank? Well, first off, way less risk, right? Fewer transactions are left just floating in financial limbo. But second, and this is just astonishing, the time it takes a person to review one of those exceptions gets cut by 2/3. It drops from almost 15 minutes down to under 5. Now multiply that by thousands and thousands of exceptions, and you're suddenly freeing up an enormous amount of skilled human effort to focus on much more important work. You know, when you look at this, it really feels like a blueprint for solving some of the world's most tangled problems. This kind of powerful optimization, it has applications far beyond just finance. Think about global supply chains, or logistics, or even drug discovery. The question really isn't if we can solve these massive challenges anymore. The real question is, which one are we going to point this incredible technology at next?